Okay, we got Digital Systems Lab here. Camera 9, of course.
Which is good.
Okay. We have a analog to digital converter and a digital to analog converter on the output. Okay. So whatever input we put on the input, we should be receiving on the output. Okay. Right now we have a 0 volt output input, 0 volt, 0 volt out. Okay. Right now we have. I'm just going to do this in steps, incremental more than what we should. But we got this left bit is the least significant. Okay. So we got 0 0. Sorry, let me find the camera. Oh, 0 0 0 0 0 1 1 1. And right there we have listed where it's 134 millivolt. And we have this meter connected to the output of the op amp, 127 millivolt. We got a 7 millivolt difference right here, okay, from the input to the output, which is not a significant amount, but I mean we got a little bit of power drop, okay, power loss, no big deal, okay.
Just expected.
Now it's expected. We're just gonna crank her up a little bit, input, you know, quite, well, maybe not quite that much. Let me turn her down with the potentiometer. Okay, it's really sensitive. I'm sorry. Whoop. Okay. 0 0 0 0 1 1 1 1. Okay. We're gonna measure. I'm gonna move this digital multimeter. What we got going in, which we got let's just say 285 millivolts. We'll just say that, okay. And then we're gonna come out here to the output, and we got 273 millivolts. You know, once again, just a few millivolt difference from the input to the output. Ain't that right?
That's right. That's right.
Okay. Now that we got validation from Cameron, we can proceed. Okay, we're just going to crank her up a little bit more here. As we increase this is going to increase the count, which is increasing the voltage, which is going to increase the output. Okay, here seems like a good. Let's see. Okay. Let's go ahead and take a couple more tests here. Okay. We've got an input voltage of 1.432 volts. We're going to measure the output here. 1.35-ish volts, okay? A little bit of voltage drop, once again. The camera, do you think this is okay?
It's alright.
Cameron says it's alright, but it don't matter. Okay, so now we're going to go back and measure the input voltage, but we're going to crank her up, go ahead and crank her all the way up, you know, at this point.
Oh, you fucking stinking ass. Hey, it's better than white smoke. Man, I mean, you just have to park in the corner.
Okay, we got an input voltage of 5.1 volts. I'm going to go ahead and switch this over to the op amp. See what we got on the output. 4.65 volts. Okay, we got a 400 millivolt drop.
It's expected, so that's all right.
It's expected, considering Cameron thinks it's expected. So just saying this is going to be okay
Because of the op amp.
because of the op amp. Now let's go to the other extreme, which is everything 0. Everything's 0 on the output. Let's see what we got on the input.
That was a cool laugh, minus the last part.
Roughly 0, which, you know, once again, Cameron,
Thumbs up. It's alright.
it's alright. Okay, now that we have figured this out, this is our circuit. Analog to digital converter, digital analog converter on the output, and an op amp circuit. Thank you, ladies and gentlemen.